So we've already learned how to solve a system with graphing. And graphing is a wonderful tool for being able to solve. However, if you wind up having a fraction in your answer or a decimal in your answer, the graph might not always be the best, most accurate way for solving. So there are other ways that can be done algebraically. And so today and tomorrow, so Wednesday and Thursday, we're going to spend those 2 days working on how to solve a system with a method called substitution. And it's a really easy, concrete method to being able to solve for your solution to your system. So one of the things that I want to make sure that you understand, if I give you a problem like 4 times 5, you guys easily can tell me that 4 times 5 is equal to 20, right? And if I said, hey, 23 minus 3, what is 23 minus 3? That is also equal to 20. So in a situation like that, I can say that 4 times 5 is equal to 23 minus 3. Okay, this statement is equal to this statement. Now they don't look alike. They're different numbers. They're even a different operation, but they yield the exact same value. They both are equal to 20. So they're equal to each other. So that's the same thing that can be stated for, equations. So if I have an equation like y equals x minus 3, and I have y is equal to 2x, these are both different ways to be able to get the value y. Okay, they are different operations, they have some different numbers, but they both in the end are going to be equal to y, which means they're equal to each other. Since they both equal y, they both equal the same thing, they're equal to each other. So I can create an equation that says x minus 3 is equal to 2x. Because x minus 3 is equal to y, 2x is equal to y, we know, hey, y is equal to y. So that means x minus 3. The process of solving for that y is the same thing as this process for solving for y. They are equal to each other. Now, once I have that set up, I can start solving for x. So in this case, because I have a variable on both sides, we got to move back to that unit that we went over with equations. You need to move the smaller x term by addition or subtraction. You've got to move that smaller x value by either adding it or subtracting it to both sides. So our smaller x value happens to be the x, right? It's a 1x. So in order for me to get rid of 1x on this side, I'm going to subtract a 1x. And then I'm going to subtract 1x from both sides. Okay, that's going to wind up leaving me with negative 3 is equal to x. So now I at least know what x is equal to. X is equal to negative 3. I am halfway done with my problem because I've solved for x. I know x is equal to negative 3. So the next thing that I need to do, because remember it's a solution set, not just one single variable, it has to be the coordinate. So x is going to be negative 3. We now need to figure out what is y going to be. So that's when we move on to the next step, which is to substitute. So we're going to substitute x equals negative 3 into one of the equations. And it does not matter which one. It has to just be one of the original equations. So it could be the y equals x minus 3, or it could be the y equals 2x, just one of them. You only need to substitute it into one. Okay, so I'm going to go ahead and go with the first one, the y is equal to x minus 3. So if I have y is equal to x minus 3, and I now want to change the x into a negative 3, so I have y is equal to negative 3 minus 3. Well, negative 3 minus 3 is equal to negative 6. So y is equal to negative 6. So I now have a value for x and I have a value for y. The last thing I want to do, though, is check it. I have two equations. These values should work for both equations. So I already know it's going to work for this one. I already know that negative 3 minus 3 is equal to negative 6. Now I want to go ahead and check to see if both of those values are going to work for the second equation. So I'm going to check it with whatever equation I did not use. So check with the other equation. Okay, so I have y is equal to 2x. I want to check to see, okay, if I replace that y with a negative 6, and I replace that x with a negative 3, is this statement going to be true? So 2 times negative 3. Well, 2 times negative 3 is negative 6. So I get negative 6 is equal to negative 6. Hey, look, it worked. So that means I do have a true solution. These points worked for both my x and my y values. So I have x is negative 3. There's my x value. And my y was negative 6. So there's my solution. Okay, and that's just the process of being able to do so without having to graph it, because you don't always have graph paper. Okay. All right, let's go and try another problem. All right, let's do something maybe a little simpler. Okay, so I have y is equal to x plus 4, and I have y is equal to 2. Okay, so, hey, look at that. I've already solved for y. Y is equal to 2. It's already told me what y is going to be. So that makes it really, really simple. That means for the next part, I just have to solve for x. And hey, like I said before, if y is equal to 2 and y is equal to x plus 4, then I just have to put 2 is equal to x plus 4 and then solve for my x. So I would just subtract 4 from both sides and get that x is equal to negative 2. Okay, so negative 2 plus 4 is going to give me a positive 2. And there's nothing to plug negative 2 into here. It just says y is equal to 2. So there's our solution. Yes, sometimes you will get problems that are just as easy as that. So x is negative 2, y is positive 2. And there's your solution. Now, obviously, you're not going to have a whole lot of problems that are as easy as that, but I still needed to show you something that's that easy, because I think that if I didn't show you a problem like this and you came across something like that, you might get confused. All right, let's go back to another situation like we had before. So if we've got y is equal to x minus 6 and y is equal to 3x. Again, both of these are in slope-intercept form, so I can easily just say, hey, x minus 6 is equal to 3x. And then I can start solving. So the first thing that I want to do is move one of the x's, the smaller x, over to the other side. So I'm going to subtract this x from both sides. That's going to leave me with a negative 6 is now equal to 2x, right? 3x minus 1x is going to give me 2x. And then I'm going to go ahead and divide both sides by 2. And I'll get x is now equal to a negative 3. So I've solved for my x. Next thing I need to do is just pick one of the equations. Doesn't matter, I pick one or the other. I'm going to go ahead and pick the first one. I tend to like to go with the first one. So I'm going to do y is equal to x minus 6. I'm going to replace the x, or substitute a negative 3 in for that x. So I now have negative 3 minus 6, and that's supposed to be equal to my y. Well, negative 3 minus 6 is going to give me a negative 9. So I now have y is equal to negative 9. And the last thing that you always want to do is check it. Make sure that the second equation works with both of those values. So if we've got, for our check, we've got y is equal to 3x. I'm going to replace the y with a negative 9. I'm going to replace the x with a negative 3, and then check to see if it works. So is negative 9 equal to 3 times negative 3? Well, 3 times negative 3 is negative 9. So this does come out to work. So there's our solution. Our solution is negative 3 for our x, negative 9 for the y. So again, you don't have to always graph. Sometimes you can just go ahead and solve it algebraically. Let's try another. And the best way to do this, and I know it seems like the notes are a little bit long, but the best thing you can do is just practice and practice and practice. Okay, so we have y is equal to x plus 15, and y is equal to 4x. Y is equal to x plus 15, y is equal to 4x. That means that x plus 15 is also equal to 4x because they both are equal to y. We set them equal to each other. First thing to do, move your smaller x variable to the other side. So we're going to subtract x, or 1x, because these are 1x's. We're going to subtract 1x from both sides. That gives us a positive 15 is now equal to 3x. And then we'll go ahead and divide both sides by 3. And we'll get x is equal to 5. Okay, so I've now solved for my x value. I'm going to pick one of the equations to substitute the x into. So I'm going to go ahead and pick the first one. So y is equal to x plus 15. Then I'm going to go ahead and, all right, so we've got our equation here, the y is equal to x plus 15. We're just going to go ahead and plug the 5 in for the x. So we now have y is equal to 5 plus the 15. And then, of course, 5 plus 15, we get a 20. So we get y is equal to 20. Okay, now that we have both of those, we can go ahead and do our check. I'm going to go ahead and just do a check off this side so I have some space to do another problem down here. So I'm going to go ahead and check it. I'm going to take the y is equal to 4x, that's the one I have not used, and replace the 20 for the y, and replace the 5 for the x, and then of course 4 times 5 is 20, so we get 20 is equal to 20. It does work for the second equation, so there's our solution. So our solution is 5, 20. Okay, let's do another one. And at any point when I give you guys a problem, you can pause it, then fast forward and see if you get the exact same answer. So you can pause it, work it out yourself, fast forward, and check to see if the answer comes out the same as what I've got. By no means do you have to sit here and wait around, though you might want to take your time with this one. Okay, so we've got y is equal to negative 2x plus 5. I'm sorry, my black ink is starting to die. And y is equal to 2x minus 7. Okay, it's the same exact idea, same exact process. We're going to set them equal to each other. So we have negative 2x plus 5 is equal to 2x minus 7. Okay, I'm going to go ahead and move the smaller x over, which happens to be the negative 2x. I'm going to add 2x to both sides. That leaves me with 5 is now equal to 4x minus 7. And then I just start solving. Add 7 to both sides. That gives me 12 is now equal to 4x. And then the last step is to divide both sides by 4. And you'll get x is equal to 3. All right, x is equal to 3. Pick an equation. Doesn't matter which one. I'm going to go with the first. Y is equal to negative 2 times x plus 5. And we're going to substitute 3 in for your x. So we get y is equal to negative 2 times 3 plus 5. 2 times 3, or sorry, negative 2 times 3 is going to give you a negative 6. Negative 6 plus the 5 is going to give you a negative 1. So we get y is equal to negative 1. Use the other equation to go ahead and do a check. So you get y is equal to 2x minus 7. You're going to go ahead and replace the y with that negative 1. And you're going to replace your x with a positive 3. So we now get the statement negative 1 is equal to 2 times 3, which is 6, minus 7. And then 6 minus 7 is equal to negative 1. So there is your solution. So you get a positive 3 for your x value, and you get a negative 1 for your y value. All right, let's try one more, and then I'll have you guys working on your own. And it's not going to be an IXL because there's another process for substitution that we're going to go over tomorrow. But at least you can start the basics of substitution on a quizzes activity. All right, so last one. Y is equal to 3x plus 8. And y is equal to negative 2x plus 3. Again, since they're both in slope-intercept form, we're just going to set them equal to each other. 3x plus 8 is equal to negative 2x plus 3. Move our smaller x value, which happens to be that negative 2x. In order to move it, the opposite of that negative is going to be a plus. In addition, inverse operations. So we're going to add 2x to both sides to cancel that out. That's going to give us a 5x plus 8 is now equal to a positive 3. Positive 3. We'll then subtract 8 from both sides. That will leave us with 5x equaling negative 5. And then divide both sides by 5. And you'll get x is equal to negative 1, a negative 1. Okay, from there, pick your equation. I'm going to again go with my first one. Y is equal to 3x plus 8. I'm going to substitute that negative 1 in for the x. So we get y is equal to 3 times negative 1 plus 8. 3 times negative 1 is going to give me a negative 3. And then negative 3 plus 8 is going to give me a positive 5. So there is my y value. All right, last step is to check it with the second equation. So my second equation was y equals negative 2 times x plus 3. So I'm going to substitute a positive 5 in for the y. And instead of negative 2 times x, it's a negative 2 times a negative 1, and then plus 3. Well, negative 2 times negative 1 is a positive 2, and positive 2 plus 3 does equal a 5, so you get 5 is equal to 5. So there is your solution. A negative 1 and a positive 5. All right. That is it for today's portion of substitution. Again, tomorrow we'll go a little bit different with substitution because in these cases, every single one of the problems were all in slope-intercept form, but as we know, that's not always going to be the case. It's not always going to be in slope-intercept form. So tomorrow's substitution is going to show you what to do when they're not both in a slope-intercept form. Okay?